Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video, we will start with a new chapter, Mensuration, Class 8, Chapter 11. So now, to begin with, previously we have learned that for a closed plane figure, the parameter is the distance around its boundary. So when we say that, what we are saying is that, say I have a rectangle, okay? So when we talk about a parameter, it is the distance, this distance. Say parameter is basically this distance plus this and plus this. So the parameter is the distance around the boundary. So this one. Then so this is a perimeter. Okay. Then when we say about the region, we speak about this part. This inside whole part is considered to be a region. So then in this case we call it the area. We found that the area and parameter of various figures such as triangles, rectangles, circles, etc. We have also learned to find the area of pathways or borders in a rectangular shape. So in this chapter what we are going to do is will solve problems related to parameter, area and other plane closed figures like quadrilaterals. We will also learn about surface area, volume of solids such as cube, cuboid and cylinder. So now see, here we have a polygon. Okay, we are talking about area of polygon. So now when we are talking about area of polygon, look at this figure. So it basically doesn't have any fixed shape, or you can say it is slightly pentagonal in nature because it has 5 sides, right? So now how are we going to find the area of such a structure or such a shape? So in this case now what they have done is, so basically what we know is, we know area of triangle, we know area of rectangle, we even know area of trapezium and maybe area of rhombus. So in this case what we are going to do is, we are going to divide this shape, this entire shape is going to be divided into things that we already know. Like we know area of triangle, rectangle, trapezium and rhombus. So we will try and divide this shape into maybe a triangle, rectangle, a trapezium or rhombus if possible. So now see, what I have done is, basically only this outer structure is given to you and you're asked to find its shape, only this much. So now see here, what they have done is, they have drawn a diagonal. This diagonal is drawn. So if you draw, okay, this diagonal is given to you, this one side is given to you and this one side is given. Now what we are going to do is, look at this. So here we will get one triangle, okay. Then we can, if we further divide it, we'll even get a right angle triangle. Again here if we divide, we'll get two triangles, and this part also if we divide, we get a right angle triangle. So now by constructing the two diagonals AC and AD, the pentagon ABCD is divided into three parts. So this, dividing this like this, we get three parts. So area of that pentagon is basically the area of ABC, this part. So it is area of this part, okay, this whole, this is the area, okay, of this ABC. Then area of AC and D, this whole part comes under another triangle, and then finally we have this one, that is AED or ADE. So the area of this pentagon is basically the area of these three triangles, that is ABC, ACD and ADE. So after adding all of these triangles, we get the area of this pentagon. So what we are trying to say here is that even if we have a shape or a polygon or say a quadrilateral whose shape is not defined to us, then in that case we can basically divide that shape into such other shapes whose properties or whose area parameter we already know how to find out. So by doing that, we will get the area of that shape. Okay. So now let's try to solve some examples. So say here first case we have the area of trapezium shape is 480 meter square. The distance between two parallel sides is 15 centimeter and one of the parallel side is 20 centimeter. Find the other parallel side. So now we know, so in this case what they are saying is that it is somewhat like this. Okay. So now whole area is what? 480 meter square. The distance between two parallel sides, this distance over here. Okay, this distance is the same 15 meter. And one of the parallel side is this, say consider this side, it is 20 meter. Sorry. So now what they are asking to find out is this side. What is the length of this side? So now we know when we calculate area of trapezium is given by half height into A plus B. H is the height. A and B are the parallel sides. Okay. So now what is given to us? First we'll write what is basically given to us. So now we know this is our formula. So what is given to us? Area is already given to us, that is 480 meter square. Then the distance. So this is given. So this is basically our height. So height is 15 meters and one of the sides A is 20 meters. So we have to basically find B, that is the other parallel side. So now let's try and simply substitute. So area we know is 480 equals to 1 upon 2 into 15 into 20 plus B. So let's rearrange 480 into 2 upon 15. So this if we cancel out, we will get 15 ones are 15, 32s are 480. So then if you multiply 32 into 2, 464. So we'll get here what will be left is 20 plus B. Then here we got 64. This 20 you get the other side equals to B. So our B is going to be 44 meters. Okay. So what we did here was we tried to construct the trapezium. Then we know the formula half height into A plus B. H is the height, A and B are the two parallel sides. So in this problem we already had the area, so we directly substituted the area half into height A plus B. Then we rearranged and we found the answer, that is the other parallel side, this side is 44 meters. Okay, then next. Now let's talk about area of a rhombus is 240 centimeter square. One of the diagonals is 16 centimeter. Find the other diagonal. So now area of a rhombus, that is also given by D1 into D2. So here D1 and D2 are the two diagonals. Okay. So again here what they have told us is area of the rhombus is 240 centimeter, right? So we already know area is 240 centimeter square. The diagonal D1 is 16 centimeter and we have to find D2. So now let's try and substitute. So area is 240, half into D1 is 16 into D2. So 240 into 2 upon 16. So this will be D2. So here this becomes 8. This will get 30. So 30 equals to D2. So 30 centimeter equals to D2. So the other diagonal of the rhombus is 30 centimeter. Now see here. The shape of the top surface of a table is trapezium. Find its area if its parallel sides are 1 meter and 1.2 meter and perpendicular distance between them is 0.8 meter. So again what they have told us is find the area of its parallel sides. Find its area if its parallel sides are, so they are saying this is 1 meter, this side, and this side is 1.2 meter. Then the distance between the two is, this is 0.8 meter. So here in this case, let's write down the formula first. So formula is what? Area of trapezium equals to half into h a plus b. So half into height we have 0.8 and a is what? 1 plus 1.2. So here what we'll get is, this we can write as 1.2 into 10. This will give 2.2. So now, so this will be 8 upon 22.2. So this if we calculate further, we will get, so this we can write further as, this will be 8 upon 22 into 22 upon 10 because we shifted decimal once. Now we can directly cancel. This will be 2 4s are 5s are, then this you can cancel, 4 1s are 4, 5s are, okay, so this will 1 upon 5, so we'll get 22 upon 25. So after finding in decimals, we'll get some answer that will be the area of trapezium in this case. Okay, so moving ahead, the diagonal of a quadrilateral shape field is 24 meter and the perpendiculars dropped in on it from the remaining opposite vertices are 8 meter and 3 meter. Find the area of the field. So that shape will take first. So it is basically something, quickly write down the, so the diagonal of a quadrilateral shape is 24. So this is 24 meter. Perpendicular dropped on it from the remaining opposite vertices are 8 and 13. So this here is, sorry, This is 8 meters, and this one dropped here is 13 meters. So we have to find, what they have asked us is to find the area of the field. Now in this case what we'll write is that, say now, so area of quadrilateral, it is given basically by half into the diagonal, okay, into the height, height 1 plus height 2. Okay, so now say here what we are going to write, this will be 1 upon 2 only. So our diagonal is what? 24, and we have our two heights, so that is 8 plus 13. So now this will become 12. So 12, 8 plus 13, so 13, and 8, 9, 10, 11. So this will be, so our answer is 252 meter square. So that is how, if a quadrilateral is given, we can find the area of that quadrilateral. Now next, let's look at a rhombus. So in this case, diagonals of a rhombus are 7.5 and 12 centimeter. Find its area. So D1 is already told, 7.5 centimeter, and D2 is also 12 centimeter. So now find its area. So formula is what? Area of rhombus equals to half diagonal 1 into diagonal 2. So we know half into diagonal 1 we know is 7.5 into 12. So this you can cancel out. So 7.5 into 6. So 45 centimeter is the area of this rhombus. Now, so this was all about these various shapes that we have already known. Now let's go and see for solid shapes. So now in earlier classes you have studied that two-dimensional figures can be identified as the face of three-dimensional shapes. So now what they are meaning here is two-dimensional, as in, see, now when I draw this is two-dimensional. Okay, so now this same thing, now say I am drawing it in three dimensions. So now this is the same part. Okay, this part is this part. So what they are trying to say is that the two-dimensional figures, this is a two-dimensional figure, and this is basically identified as the face. So this is one face, then there is another face here, this face is there, then back side there's one face on this side, and then below underneath there's another face. So in that case what they are saying is that this two-dimensional figure becomes the shape of this three-dimensional figure. So this is just one shape of it. Observe the solids which we have discussed. So now see, there is a cuboid. So this point here at the corner, it is known as the vertex. Okay, the point at the corner is the vertex. So now in this cone, say this is our vertex. Then we have the face. So we'll have here 1, 2, 3. On this side there will be 1 and 3, and here on the back there will be another one, and underneath. So we have 6 faces to this structure. Similarly, let's try and count the vertexes. So 1 is this, 2, 3, 4, 5, 6 and 7. And here there will be another one somewhere in the center, 8. So it will have 8. And these are the 6 faces. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. So these are the different parts of any given shape. So now look at this. This is a cuboidal box. So what we are saying about this box is that all 6 faces are rectangular and opposite faces are identical. So there are 3 pairs of identical faces. So now all of them are firstly rectangular. And now see, this top layer is going to be same as the underneath. This is going to be same as this, and this is going to be same as this. So we'll have 3 identical pairs. When we talk about pairs, so this and this side is going to be one pair. This and this one will be another pair. This and underneath will be another pair. So they are going to have 3 identical pairs. Now let's look at the cylindrical box. So in this case we have a curved surface and the circular base and top are identical. Now in this case this and this are identical. So this is one identical pair here and one curved surface and 2 circular faces which are identical. So these are the 2 faces and this is the one curved surface. Did you notice that cylinder has congruent circular faces that are parallel to each other? Observe the line segment joining the center of circular faces is perpendicular to the base. Such cylinders are known as right circular cylinders. So look at this. In this case, what they are saying is that the cylinder has congruent circular faces, which is this. So this is the congruent circular faces and they are parallel to each other. Parallel means like this when they are in this form. So one is here and one is here. So they are parallel to each other. Then say now there is a line segment that is joining both the circular faces and that line segment is now perpendicular. Perpendicular as in like this. So these are the 2 faces and these are the line segment that is joining and it is perpendicular. Perpendicular is always in this direction. So therefore such cylinders, they are known as right angled circular cylinders because see it is forming some kind of right angle here at this point and some right angle over here. Okay, so in this part of the chapter we saw how to find the area of trapezium. We saw how to find area of rhombus. Then if any quadrilateral is given to us, how do we divide that quadrilateral and find its area? Then also we saw some of the solid shapes. We understood the relation between 2-dimensional and 3-dimensional shapes. We understood what are vertices, faces and edges. Then we saw structures that have identical pairs of faces and we also learned what are right circular cylinders. Okay, so thank you so much for watching today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.